Yeah, nice to see all of you. Hello, hello. So, today I will tell you something about synthetic data, but also other things, prompt engineering. And since we are not so many, maybe you can also highlight a bit your specific interests. So, I'm personally very much interested in engineering. Who's also interested in engineering? Okay, yeah. Then you got the right talk, I guess. First, I tell a bit about the company I work at. It's called Jina AI. And what we do is we create our search foundation. And all of you might have heard about foundation models. And usually we mean these models, these large language models. They're used for generative tasks, but generative AI is just a subfield of all the AI. And we work on the specific field of search, because we think even in the future, some people talk about like the end game of AI, search will be highly relevant, because who wants to have all this generated data when you also could have like these ground truths? You have to ground yourself to real world, otherwise everything becomes also a bit weird and useless. So here we are at the moment. So we are founded in 2020, have our headquarters in Berlin, 36 employees, and yeah, you can see a lot of registered users already. It was not always like this. We were growing very slowly by adapting in the open source community, and this was a very long process until we can say we have so many registered users. So what is a search foundation? Foundation model for multimodal search. This is our core mission in our company. And just to give you some inspiration on what this could mean, it means embedding models. Who knows embedding models? Yes, that's good. Re-rankers, so embedding models are used to retrieve some search results, but they might be of low quality. And then you have a re-ranker that shuffles them a bit around to improve the quality a bit more. More compute, but on the other hand, better quality. That's what we want for search results. And then what's also part of Search Foundation is the auto fine-tune. Describe a problem in some abstract language, like a search problem, and then automatically get this synthetic data generated for fine-tuning that specific model. And we see it's really necessary because even the best embedding model cannot fit for all the use cases. And if it does, it must be very huge and inperformant. So you always want to have your fine-tuned models for your use cases, especially in like e-commerce or so, where you really count seconds or even below seconds in response time to give the results to user. And then this is something you might have heard already because it went really popular, this reader. It is a way to access all the websites in an LLM-friendly way. So all the AI agents, they don't have to parse complicated HTML and find out where do all these elements belong and what does this website mean. They can use a reader to read the text in some markdown format, which suits much better to them, or also see the screenshot of the website if it's a vision language model, for instance. Then here are some models shown. And of course, it's not really useful to go step by step through the whole list and memorize all our models. But what I want to show is that we have some models that are turbo, for instance, turbo re-ranker for fast inference with a bit less quality, and then also a bit larger models. We support multiple languages and so on. And we do a lot of research because we found out as an AI company nowadays, it's not enough anymore to just call yourself AI, like it was at some point. You really have to prove yourself. Everything becomes AI, and there are so many people just hop on this AI train and also claim their products being AI, that you have to prove yourself. And we do this by doing real research, going to conferences, hand in papers, and participating in this whole process. And it pays out so far. So just to name some KPIs, so for instance, all our APIs I described before, like embedding and re-ranker and so on, process 2 billion tokens per day. Of course, the number we want to increase over time, but it makes me now much more confident about our company. And some market segments, internet, telecommunication, finance service, law, government, a bit of healthcare, and these are the main customers. We can see this from the data they send us. And these are the featured clients I just want to put here. So this was the marketing slide. Let's jump into probably more of a reason why you're here. I tell you something about RAG, something about, not too much about RAG. I see some eyeballs rolling. About a concept that builds on top of RAG that we call ZAG, that you probably didn't hear before, and why synthetic data generation is useful in the whole process. And I start a bit with prompt engineering. So is your LLM output not as you expect it to be sometimes? Yeah. And who do you blame, the model or yourself? I blame myself. Hey. So if you blame yourself, then you have good potential becoming a prompt engineer, because it will motivate you to over and over fine-tune your prompt, make it a bit better, maybe add some other data, split it up, and so on. And this iterative process is called prompt engineering. So I think myself a bit of this movie, Groundhog Day. We have to live through the whole day over and over again. But every day, even though the same things are happening, you can modify it a bit. And this leads to a bit of different output. And I see prompt engineering exactly like this. So let's iterate over an example. So my first initial prompt was write a story, and I already had this nice cat story in mind where the cat is going through space and so on. And then ChatGPT writes a really boring story about cats. And I think like, no, this ChatGPT, why could you not generate something I had in mind? Yeah, because I didn't formulate it like this. So I improved my prompt over time. I say, it's about a cat and addresses 6-year-old children and so on. And at some point I realized when I add really a lot of instructions, the model is not really capable of following all these instructions anymore. It's just ignoring this one or this one. But what I can do then is, this is the next thing in my daily prompt engineering, that I split up this prompt into multiple ones and chain them. Because each of the single prompts is much easier, has less instructions, and it's easier for the model to understand. So for instance, first I generate the first part, and in addition to some general instructions I'm adding, I also add, this first part should be very funny. I mean, ChatGPT is not so good in creating fun, but I mean, the main message I think I can deliver here. Second part, I say there is a plot twist, and I also insert, this was the first part, it needs to start somewhere, right? And then at the end, there should be a moral lesson. And I can do this splitting further and further until I have a really long chain with a lot of complex prompts, then generating my story. And if I did it in the right way, then I should experience much better output than with just a single prompt where I expect everything to happen. So another thing is, I see often where it's a bit of a misconception, or people blame rather the model than their own prompt, is, for instance, this prompt. So optimize the following prompt. Find a cake recipe and translate it into German. Pretty clear, right? But the thing is, it can mean two different things. It could, and this becomes obvious when we start adding some structural elements. So when we add, for instance, this 4 sharps here. So optimize the following prompt, and then it's clear for the model, and it starts here and ends there. And then translate it into German means it first find the cake recipe, or no, find the cake recipe is like the prompt, and it will first optimize. It will say something like, oh, this delicious, whatever, chocolate or so, and then translates everything to German from this output. But in the second one, where I put the structural elements a bit differently, this whole thing becomes a prompt, and it will just output and translate the whole prompt as it is. Then another feature is function calling that is also often not used enough, I think. So very simple, we say what is the temperature going to be here tomorrow, and then it first finds out about the current date and get current location by generating the function call. It waits, and then only after we return the return value, give the return value from the function calls to the model, and it's those two. Then it decides to make another function call, and then finally generates the output when it has collected all the data. And yeah, this is useful prompting technique. Why not using it? And here I listed a bit what I think is what a prompt engineering journey should look like. So you start from your zero-shot prompt, and then you have the realization it doesn't work, like always. It won't work on first try. But then you have to think of, why doesn't it work? Maybe it works because following instruction was too hard for the model, or I have a lack of data and more grounding is needed. And based on this observation, you decide where to go from here. For instance, if like more instructions, instruction following is too hard for a model, yeah, take a bigger model or whatever, but at the end you will hit this limit, then you should do this chain of thought, splitting up the prompt as I described before. But you already can go a bit into fine-tuning. But fine-tuning, on the other hand, also helps a bit on grounding, putting factual, correct information into the model so that it can give correct answers. But even a better way of grounding is using RAG-like applications and web search and so on, function calling. And this is something you cannot achieve with fine-tuning. So yeah, so you have to find your way. And there are many more prompting techniques that I think could all fit in this kind of diagram here. So another thing is what we develop at Jina is something we call Aikido prompting. So you can go through all the fights with the model and even threaten it to give you the right output. But what about you just try to go with the force of the model and take your enemy's attack as advantage for yourself? So in this example, I ask it to generate something that is a markdown format, and I explicitly say you must not generate the title, only the content, not the title. And what is the first thing it does? It generates the title. So it's possible at the end to really make it do this, but many more instructions. And we don't want to eat so much instructions, because then we cannot instruct it with other things, right? So a better way is, why not just generating the title? If it really wants to, then we should not force it. We have other coding technologies like parsing or splitting text, splitting a string into multiple parts. So why not explicitly telling it, if it wants, then please generate this title, and we know with high confidence it always generates this title, because even without this instruction it tends to do this. And then we have a very predictable format, and we can just remove the first line. Done. And we have less instructions. So now I introduce you with something else. So another weakness I see in current AI applications is that I think they are not creative enough. And let me exemplify this here. So I told you I want to generate synthetic data, and a couple of years ago when I had a problem, I typed it into Google, but now I'm an AI engineer, so I asked ChatGPT to do this task. So to train an embedding model, I need around 100,000 samples, question-answer pairs, at least for fine-tuning the embedding model. So let's ask ChatGPT directly. Return a list of 100,000 question-answer pairs. But then ChatGPT broke my heart. I thought we were friends, but actually it says it goes beyond the scope of our interaction here. How could it betray me? So, but if ChatGPT is like this, then I can also be like a bit tricky, or apply some tricks. So just 10,000 times I ask it to return 10, very random. It must be very random, because otherwise we have duplicates, right? Question-answer pairs. And let's see what it does. Ha! Got it. So these are the first three. Then I didn't continue because I saw this. Already in the second try, it was generating the exact same thing. Even I told it to be very random. But actually it's like this. So it's full of duplicates. I wonder if I could, with this method, even pass 100 questions. I think it's not even possible. So we need more creativity. I hear very often, why do you use ChatGPT? I use it because it's so creative and it lets me come to other thoughts and so on. Yeah, probably, but most likely because we don't insert the same prompt 100,000 times or something, because then it becomes very boring, even after 3 times, as we could see. There is a way, so mentioning this, we need more creativity. What is actually creativity? So now we have a definition of creativity from psychology, where what is called the OUGHT test. It's a test where the test subject has to name as many as possible alternative uses for an object. And for this brick, maybe another obvious use would be maybe to construct a building, but maybe also use it to block a door, or to smash something, or maybe put some flowers in these holes, or whatever. And in the following slide, there is another object, and I want everyone to think of as many as possible alternative uses for this object, and also think a bit about the process, how you came up with. I mean, it's hard to, but it would be very interesting to me to see. So 3, 2, 1. Have you seen this object before? So what could it be used for?
Unlocking the door.
Yes.
Hmm?
wrote some paper together, yes? Oh, wonderful, yes. Of course, yeah. Maybe not so, yeah. SIM card, yes. Yes. Oh, wonderful, yeah. One of my beloved ones. As a bookmark, yeah, to put it there, yeah. Maybe like 3 more, because then we have 10. Yes, for a nice, I could do this, yeah. Then 2 more. Yeah. As a random conversation on a meta level, yeah. Nice, very, very nice. And now I would like to that you think about how did you approach this problem? Because as a prompt engineer, this is a question I often ask to myself. The first few times I solve this task by hand, just on my own. And then I think about what were my thought processes approaching this task, and how can I translate this and make single prompts to simulate the same thought process so that the model lives through some similar technique. Because asking it directly doesn't work, but someone has an idea? How did you came up with this mobile phone? Mm-hmm. Like maybe some simulation with this object in daily life. So here are common strategies. So most people first retrieve certain memories. For instance, the brick reminds them immediately on an old van that the father had, where this brick was used to block this van from rolling or something. And then what also helps is looking around. Oh, my phone. Okay, then maybe it can be used for a SIM card, or looking at other people, finding actively new clues to stimulate your creativity. And then a bit later comes usually where people think about properties. So this is something heavy, I can use it to block or through, or is this light thing, I can maybe bend it. And coming from these properties, then thinking about the actual use case. And yeah, I would be very interested in more strategies, because this could help me a lot creating more and better and more diverse synthetic data, training data. So this is where I see the parallels and also differences to RAG. As you know, with RAG, you give the model a task and tell it, yeah, here's your database. You can write a search query and then research in that database, and it outputs a search term, and then you retrieve the results. And with the result, the answer generation is more focused, more nailed down to solve a specific problem. And then in ZAG, this is not retrieval augmented generation, but stochastic augmented generation. You have some random noise. You give in some random noise. Because if I have, for instance, this brick, and then I give you the random word boat, for instance, then you might immediately think of, I use it as an anchor. And this, just a random word added allows you to come up with new ideas that can be actually useful. And here we see it in application. So for instance, I ask just normal ChatGPT, I come into the office in the morning, generate a creative thing I can do, answer in 10 words, okay. It was a creative thing. First, maybe starts a bit creative, collaborative themed photo contest with your colleagues. Okay, then it's again themed. Something is themed, and it's again collaborative. So maybe not so creative when you think of diverse answers, but it's a bit of different things. It's a playlist. Okay, then here's a poem. Then later it's also a haiku, which is almost like a poem and so on. But what if we apply now our new creativity power method to this? Then we say the exact same prompt, but we add another instruction where it says the answer must center around the topic, and then it's just a random word. And now it comes up with fancy ideas. So for instance, topic is bee, and create a bee-friendly plant corner with educational info cards. Maybe not so useful in my daily life, but it's original. Miniature lake scene on your desk with supplies, like a shower thing with inspiring office-themed quotes, and so on. So you can really see something is happening, and every time you make a prompt here, you're just surprised, like a bit surprised, almost like you would use ChatGPT for first time. It's not so predictable anymore what comes out. And as I told you before, we do real science. So we also did an experiment here and checked on these odd tests. So there are some of these results of alternative use tests from university with thousands of participants. And then we used the same test where we already had the human evaluation data to check how good the models perform. It's still a difficult task, and this work is still not published. So because there is a lot to consider here. But generally speaking, we can see we surpass then in originality the human performance. We can come up with many more original ideas with this method, and small models benefit more from this method than large models. So the GPT 3.5 Turbo was only barely able to be original at all, and with this method it is somehow. But then I talked about originality and creativity. These are actually two different things, and in fact creativity often is described as originality plus effectiveness, or times effectiveness, or some dependence on both of these things, because it's not really creative to come up with a lot of ideas that are not effective. So you could come up with, I make a stone fly in the air because it's light, or use it as an airplane. But it's very original, but it's really not effective, and therefore it's also not creative. I think a lot of people think just some original ideas are so creative. No, they're only creative when they're also effective. And we can see that this method harms effectiveness, but it doesn't harm as much as it improves the originality. So we can see here with GPT-4 and also 3.5, effectiveness goes a bit down. And here is, so these are generated training data. So these are queries that were generated. As you know, for embedding model training, it's a very good idea to have a lot of different question answer pairs from different subjects, from different domains, when you want to publish a model that is good on all these general benchmarks. And what we can see here is that with a standard prompting technique, all the queries are very clustered. And then you can see it has this favorite topics of quantum computing, cooking recipes, lifestyle things, like a typical renewable energy, the typical ChatGPT favorite topics. And then with our approach, it's a bit more feathered out, not so many clusters. But yeah, as you see, it can also be improved. So you see some structure still. And ideally, it would even less clustered. And this is another way of seeing that this method actually works. You can calculate the average cosine distance to the nearest neighbor. When you have all the queries as embeddings and then embedding space, you can, for each query, you can check how far away is actually my nearest neighbor. And then you do this with all of the queries, and you build the average. And then, and here, even putting them in a histogram. And we see with a standard prompting approach, a lot of queries have a very small cosine distance to their nearest neighbor, so have some duplicates, or almost near even duplicates. Some of them have distance 0. But for the other approach, for our approach, we see, if something is already here, then it's really a different query. But we also have some that are quite similar, so it's always something we can improve there. And this is again something what I think from psychology we can learn, because we have these two concepts of RAG and ZAG, and this reminds me a lot on convergent thinking and divergent thinking, where in humans we have constantly the change between we think divergent in any directions, but then nail down our focus on certain things, evaluate all possible branches, and then only proceed those that are actually worse going further. So we need both. For certain situations, we need this creative view, and for others, we need really to solve this specific problem without any creativity. And I think the agents in the future, they will have this concept implemented, and we make good experience with our agents when it comes to search. So at some starting point, it diverges a bit, ideas, but then at the end, it's again focused down to some core idea, and this process goes further and further like this. And you might know this prompting technique is called tree of thought. And this is actually something that fits very good to this idea, because, so who knows tree of thought? One person, okay. So this is about, you start with an input and a problem you need to solve. Let's think about a programming problem. Write this complex programming project. And then you could, for instance, write a project about a visualization of 3D objects. And as an engineer, there are many ways you can go from here. So you could first look at all the libraries that you could use, and use like this library or this one. Okay, this is a bit more outdated, but on the other hand has a great community, and evaluate all these things. But then at the end you decide for one of those. And these are the three branches here, where you first just randomly choose these libraries and see how far you can go. And for one of these libraries, you see immediately, oh no, there's no way we can go further, because it's not even possible to pip install or something. And then this branch is completely ignored for now. There's no way further. But you have other branches where you can continue, because you could have also started with that package. And as we can see, these both packages are able to install. And from there, you can write like a first program, but then you encounter more issues, maybe a runtime error, and this leads at the end to this branch also doesn't work, and so on. And this is a continuous interchange between thinking diverse, trying out of all of the possibilities of partial solutions that are a bit closer to my final solutions, and then also shrinking down again and being very rational and evaluating, is this partial solution, does it really have any chance becoming the final solution? So yeah, and all of what I described, think of Groundhog Day. Every time, iterate over your prompts and try to make them better. And yeah, there's no reason to wait for GPT-5 or something. We have really capable things out there right now. And if someone wants to know more, then I have also a lot of complicated slides on how we created training data and evaluation and everything. So we have enough to talk. But I would be curious about what do you think? Thank you.
Any questions?
Thank you. Is it something you use to train new embedding models at Jina AI, for example? Like using synthetic data?
Sorry, can you repeat?
Like Jina AI is training embedding models, right? So
yeah, embedding models, re-ranker. Yeah.
So are you using like synthetic data?
Synthetic data, yes.
It's very hard to pronounce.
Yes,
right?
yes.
And have you seen like an improvement?
Yes.
Like for like the embedding models and everything?
So overall, it's green. So this shows, show all our improvement. So it's possible with our current framework to say what is a domain the synthetic data should be generated for, it's medical domain, then define the length of the queries and also the length of the documents. And then it starts generating training data with the described approach. So it doesn't sample randomly from all the words to get inspiration for the training data, but it first generates the whole dictionary of words and then samples from the words. And actually, this is also like a recursive step of our ZAG method because it samples from the letters in the alphabet and takes this as inspiration to find a term in that domain. So for instance, also if you have to name all engineering terms, you would be like, I don't know even any. Okay, Docker, now I found one. But if you go like through the alphabet and for each combination of letter you have to find one word, then it's easier. Find company with A, Alpha, with B, Bayer, and then it's the same applies for the model. So we generate this dictionary for these domains here, and then along with how long the query has to be and the document be, we create this synthetic data. The process of creation is described here, but yeah, before we dive into this, or we can also answer other questions.
Anyone?
Hey, how do you measure the validity of the result? So you say when you converge, like make sure that it's like a valid output. How do you judge? I mean, does the system does it on itself, or does it rely on human input? Or?
Do you mean how we can measure the quality of the generated training data? Is this the question, or?
Yeah, the quality and the validity. If it's like a valid company name or whatever.
This we don't check. And it could be that also some incorrect information is part of this, but we only take the end-to-end metric to compare. Like looking at the public benchmarks, is this the MTEB evaluation data set, for instance, is this improving when we use our synthetic data for training? Of course, in the development process, me and my team were looking into the data and then finding out, oh, this is looks incorrect or so. So maybe we adjust a bit the algorithm until we didn't see anything more that didn't look plausible. And then the only way to measure for us was, okay, we just train a model or use it for fine-tuning, and then we see if it actually improves the accuracy. And therefore judging, okay, and it seems to be good training data if it improves our scores. But yeah, but it's, I also see that it's not, might be not the final truth of everything. Yeah?
But I mean, it's dependent on the domain, right? If it's like the output is critical, like there can't be any like bad results in there, then you produce more entropy and need to filter it out afterwards. No, I mean, do you know what I mean? So so I mean, like whatever, invent like a funny story. That's like easy. But if you want like, I don't know, give me all possible names for like a medicine that is valid in countries. So, I mean, it's like a complicated example, but if you rely on the output to be like factual correct, like how would you do that in this case?
Yeah, I think then Gemini with its grounding would be the best for us to use, because there's a model with a proprietary model with the best grounding at the moment, 1.5 flash, and yeah, I think this method would also benefit from having grounding there for sure. For now, we just trust it on the ChatGPT knowledge, which is actually not a good idea, but hey, it worked at the end.
Do you do benchmarks on commercial models? Which model generates the best training data? So do you use only OpenAI, or you now mentioned Gemini or Claude or Llama or things like that?
Very, very few. I tried back then with Mistral 7B and the one that has 8 times 7 billion. But even from looking at the data, it looked very bad to me. So I didn't even try to do this. It also comes with a lot of effort, then doing the fine-tuning, everything. Only thing I compared was GPT 4 Turbo and GPT 4o. And then this O was slightly better. But yeah, would be interesting to see. Maybe I blame them incorrectly, or I should actually try also more open source models.
Other questions? No? Well, thank you so much, Florian, for your presentation.
Yep.
Round of applause.
Yeah.